Why are circuit breakers so crucial to our everyday lives? They're like the unsung heroes of our electrical systems, quietly protecting us from potential electrical hazards. Today, we're going to delve into the world of circuit breakers, understanding their different types and the roles they play. First, we have the magnetic circuit breakers. These are the most basic type of breakers. They contain an electromagnet that gets activated by the electrical current. When the current exceeds the breaker's capacity, the magnet triggers, causing the circuit to break and stop the flow of electricity. These are often found in residential and commercial settings. Next up, we have thermal circuit breakers. They function based on the principle of heat expansion. When the electrical flow increases beyond the breaker's capacity, it heats a bimetallic strip or a solder pot within the breaker. This heat causes the strip to bend or the solder to melt, breaking the circuit in the process. They're commonly used in appliances like coffee makers and hair dryers. Our third type is the magnetic hydraulic circuit breaker. This combines the principles of the first two. It uses a magnetic coil and a hydraulic delay line. When the current exceeds the breaker's capacity, the magnetic coil is activated, but instead of breaking the circuit immediately, a hydraulic delay line slows the process, minimizing the chances of unnecessary circuit breaks. Then we have the common trip circuit breakers. These are used in places where several circuits need to be shut down simultaneously. If one circuit in the breaker trips, all the others do as well. They're often used in industrial settings, where a single fault could potentially impact multiple circuits. Finally, we have the ground fault circuit interrupters, or GFCIs. These sophisticated devices can detect an imbalance in the electrical current between the hot and neutral wires. If it detects even a slight imbalance, it shuts down the entire circuit, preventing potential electrocutions. They're usually installed in areas with high moisture, such as bathrooms and kitchens. To summarize, magnetic circuit breakers work on the principle of magnetism, while thermal circuit breakers operate on the principle of heat expansion. Magnetic hydraulic circuit breakers combine these two principles and add a delay to prevent unnecessary circuit breaks. Common trip circuit breakers, on the other hand, are designed to shut down multiple circuits simultaneously in case of a fault. Lastly, GFCIs are designed to detect and prevent potential electrocutions by monitoring current imbalances. Remember, each type of circuit breaker has its unique characteristics and applications. Understanding these can help you appreciate the role these silent guardians play in keeping our electrical systems safe and operational. It's a complex world of breakers out there, but with a little knowledge, it becomes less daunting and more fascinating.